Welcome to my channel. Today we are solving a fascinating problem, that is a minus b equal to 2, and another equation is a power of 5 minus b power of 5, that is equal to 992. At first glance you might think, let's substitute a equal to b plus 2 in the second equation. Then our second equation turns into b plus 2 whole power of 5 minus b power of 5, that is equal to 992. To simplify using Pascal's method, we can find the values of b. But hold on, this approach may lead you to incorrect solutions. In this video, we will explore number 1, why this initial substitution does not work, number 2, the correct techniques to solve this problem. Let's start with the seemingly obvious substitution a equal to b plus 2. Use the Pascal's method. B power of 5 plus 5 times b power of 4 times our b value is 2, that is 2 power 1, plus another number is 10. So 10 b power 3 times 2 power 2 plus again we have 10. So 10 b power 2 times 2 power 3 plus again we have 5. 5 b power 1 2 power 4 plus the final one is 2 power 5. B power 5 plus here 5 times 2 is 10 b power 4 plus now we have 10 times 2 power 2 is 4, that is 40 times b power 3. Now we have 2 power 3 which is 8, 8 times 10 it is 80 b power 2 plus 2 power 4 is 16, 16 times 5 is 80, 80 times b plus 2 power 5 is 32. This is b plus 2 whole power 5 value. Still we have minus b power 5. Just take it minus b power 5, that is equal to 992. Here plus b power 5 and minus b power 5 gets cancelled. Now we are only this expression, that is 10 b raised to power of 4 plus 40 b raised to power of 3 plus 80 b raised to power of 2 plus 80b plus 32 equal to 992. Now both sides divide by 2, then you will get 5b power 4 plus 20b power 3 plus 40b power 2 plus 40b plus 16, that is equal to 496. If you take this 496 to the left hand side, then it will become 16 minus 496, which gives minus 480. Now by using long division method, I am going to find the values of b. For that, just take the coefficient of all the terms, that is 5, 20, 40, again we have 40, the last one is minus 480. Let's do with 4. Now if you do again with the minus 2, then you will get the roots are b minus 4, b plus 2, and then we have 5b power 2 plus 10b plus 60 equal to 0. This is in the form of quadratic expression. So using quadratic formula, we are going to find the values of b here. Before that, let's take these two values of b. B minus 4 equal to 0, that means b value is 4. So we consider a equal to b plus 2, that means 4 plus 2, which gives 6. So if b equal to 4, then a value is 6. If b equal to minus 2, then a equal to minus 2 plus 2, which gives 0. So if b equal to minus 2, a value is 0. Substitute these values in the equation 2, that is our equation 2 is a power 5 minus b power 5, that is equal to 992. So first a values are a equal to 6, b equal to 4. So a value is 6 power 5 minus b value is 4 power 5, that is equal to 6 power 5, the value is 7776 minus 4 power 5, the value is 1024, which is 6752, which is not equal to 992. Unfortunately, this solution does not satisfy our second equation. So let's try another approach. A equal to x plus y and b equal to x minus y. Why I am choosing a equal to x plus y, b equal to x minus y? Because This substitution eliminates one variable, reducing the problem to a single variable x. In this case, the difference of fifth powers becomes easier to factorize. That's why I'm taking a equal to x plus y, b equal to x minus y. These two values, if you substitute in the first equation, then our first equation turns into x plus y minus of x minus y, that is equal to 2. Here plus x minus x gets cancelled. So 2y equal to 2, so y equal to 1. So we found y value. Now we need to find x value. So that's why let's substitute these values in the equation 2. So a power 5, that means x plus y whole power 5 minus x minus y whole power 5, that is equal to 992. And just now we found that y value equal to 1. So substitute here. So then x plus 1 whole power 5 minus x minus 1 whole power 5, that is equal to 992. Now just recall the Pascal's triangle. So this is the Pascal's fifth powers. That is 1, 5, 10, 10, 5, 1. Using the binomial theorem, we are going to write this. So first expression is 1 times x power 5 plus 5 times x power 4 times b, our b value is 1, plus 10 x power 3 times 1 power 2, plus again we have 10. So 10 x raised to the power of 2 times 1 raised to the power of 3, 5 x raised to the power of 1, the last one is 1, plus 1 power 5. This is for x plus 1 whole power 5 expansion. Now we will write x minus 1 whole power 5 expansion using binomial theorem. So here minus of, same we write the expression as same, only the alternate signs will be changed. That is x power 5 minus 5 x raised to the power of 4 plus 10 x raised to the power of 3 is minus 10 x raised to the power of 2 times 1 power 3 plus 5 x raised to the power of 1 power 5, that is equal to 992. When you open this bracket, this x power 5, it turns into minus sign. This is minus x raised to the power of 5, and this minus it turn into plus, and this plus turn into minus, and this minus turn into plus, and this plus turn into minus, and this turn into plus. Now observe, plus x power 5 minus x power 5 gets cancelled. Then 10 x raised to the power of 3 minus x raised to the power of 3 gets cancelled. Plus 5x minus 5x gets cancelled. So you are left only with 5x raised to the power of 4 plus 5x raised to the power of 4, which is 10x raised to the power of 4. And then you left 10x raised to the power of 2 plus 10x raised to the power of 2, which is 20x raised to the power of 2. And what you left 1 raised to the power of 5, that which is 1 raised to the power of 5, which is 1. So 1 plus 1, which is 2. That is equal to 992. When you send this to left hand side, then you will get 992 minus 2, which gives minus 990. That is equal to 0. If you do divided by 10 on both sides, then you will get x raised to the power of 4 plus 2 x raised to the power of 2 minus 99. That is equal to 0. This x raised to the power of 4, we can write this as x raised to the power of 2 whole power 2 plus 2x raised to the power of 2 minus 99, that is equal to 0. Here we have x raised to the power of 2, here we have x raised to the power of 2. To make it easier, let us consider x raised to the power of 2 equal to t. Then our expression turns into t power 2 plus 2t minus 99, that is equal to 0. It is an quadratic equation. Using quadratic formula, we are going to find the values of t. So then t equal to, what is the formula? Minus b plus or minus square root of b square minus 4ac by 2a, that is equal to minus 2 plus or minus 4 minus into minus plus 99 times 4, which gives 396. 396 plus 4, which gives 400. So square root of 400 over 2. Square root of 400, the value is 20. If 2 take it as common, then you are left with minus 1 plus or minus 10 by 2. This 2 and this 2 gets cancelled. So then you will get minus 1 plus 10, which gives plus 9. The solution is minus 1 minus 10. So minus 1 minus 10, which gives minus 11. So our t values are t equal to 9 and t equal to minus 11. Now substitute back in our equation. We consider x power 2 equal to t. Take t as 9, then x equal to plus or minus 3. Similarly, here x power 2 that is equal to minus 11, then x equal to square root of minus 11 plus or minus, which is equal to plus or minus root 11I. So these are the x values. And also we found y equal to 1. And starting we consider a equal to x plus 5, b equal to x minus 5. X values are plus or minus 3 and another x values are plus or minus root 11I. A equal to, first take x equal to plus 3. We know that y value is 1. Then a equal to 4. Similarly, if you take x equal to plus 3, then y equal to 1, you will get 2. So x equal to positive 3 case, a value plus 4 and b value is plus 2. This is one solution. If you take x equal to minus 3, so then a value is minus 3 plus 1, which gives minus 2. So b value is minus 3 minus 1, which gives minus 4. So when you take x equal to minus 3, we got a equal to minus 2, b equal to minus 4. Now let's take x equal to plus root 11I. A equal to x plus y, that is root 11 plus I. The y value is 1. So this is the a value and b value is root 11I minus 1. Now x equal to minus root 11I. So in this case we got a equal to minus root 11I plus 1 and b value is minus root 11I minus 1. Here two values and here two values. We got these a and b values. I hope you like this content. If you want more content, subscribe and I will keep creating. Thanks for watching.